Hi kids, how are you guys doing? Today we're gonna be talking about mixtures and solutions. What is a simple mixture? What are different types of mixtures? Let's go with Sam to define mixtures.
Hey, birthday girl.
Sam, what's up? I'm just setting out some munchies for the party.
Sweet. I brought the cake Mia and I made.
Aw, this is awesome! You guys rock!
What you got here?
Just a few mixtures of some tasty treats. Have some.
Ah, mixtures, my favorite.
How can mixtures be your favorite? That doesn't make any sense.
I don't know. I like mixing things. It doesn't always have to make sense. I'm an artist.
Sam, do you even know what it means to be a mixture?
Not really. But I'd be happy to have you enlighten me while I snack on these.
I'm sure. Mixtures are physical combinations of two or more substances that retain their properties when you mix them together.
As the girl said, mixtures are a combination of different substances. Let's try to make some mixtures ourselves. For example, we may mix things while in the kitchen, like you can mix sugar with water, or while working outside, like you can mix some sand with water. You can also mix some salt with water, like the mixture in the third cup. So, mixtures is when two or more substances are combined, but each substance keeps its physical properties, which is a characteristic that can be measured or observed.
Right now we're going to do an experiment. I have one bowl of water and another bowl of water. They're completely the same. I'm going to put the rosemary and the sea salt into the water and see what happens. I'm going to use my wooden spoon and try to mix them in as best as I can. We're going to start with the salt. I'm going to pour in as much salt as I think is necessary. And then take my spoon and mix it in. The final result is that the salt has completely dissolved in the water. There is no traces of salt anywhere within the bowl. Next, I'm going to pour the rosemary into the water and try to mix it in as best as I can. As you can see, the rosemary has not dissolved in the water at all.
Since mixtures are a physical combination between substances, this should mean that a mixture can be reversed or separated after being combined. It isn't always easy to separate a mixture, but just because something is difficult doesn't mean that it's impossible, right? Like in the case of rosemary and water, you can separate the components of this mixture by picking out the rosemary pieces with your hand. Let's go for another example. Let's say sand and water. How can we separate this mixture? This can be done using a filter paper. The filter paper will catch the sand particles and will allow the water to move through it. What about another example? Salt and water. Separating this mixture cannot be done using a filter paper, since, like you saw in the video, the salt particles are dissolved in water. So, all of the solution, all of the mixture will pass through the filter paper. So, what can we do? Let's try to leave the mixture of salt and water in a sunny place for 2 days. Or you can heat this mixture. Heating it will help the water evaporate, leaving the salt behind. So the water evaporates, the salt in the water is left in the container in the flask. Mixtures are everywhere. For example, when we bake a cake, it's a result of a mixture of eggs, flour, sugar, and other ingredients. But mixtures can also be much simpler than that. This plate of candies is an example of mixtures. But beyond the things we eat, our environments are full of other mixtures. Mud and water, for example. Orange juice, chocolate and milk, coffee. coffee, tabbouleh, cookies and chocolate. All of these examples help us know that a mixture is a combination of different things. We are mixing things together to get different mixtures. Ready for more examples of mixtures? Rock and sand. Soft drinks. In a soft drink, you'll see that water, sugar, and gases are combined. Mixing water and vinegar. Milk. But how are all of these examples of mixtures alike? How are they different? What are different types of mixtures? Let's check in the next video.
In this video, we're going to talk about the difference between a homogeneous mixture and a heterogeneous mixture. But what do you think the difference is between these two types of mixtures? A homogeneous mixture has visibly indistinguishable parts. All you could see is one clear solution. In a heterogeneous mixture, you can see multiple distinguishable parts. A homogeneous mixture has uniform composition. The composition is the same everywhere in the mixture. And a heterogeneous mixture is not the same. The composition can vary by position. So let me give you an example. Salt water is a homogeneous mixture. When you look at salt water, all you could see is one clear solution. You don't see two distinguishable parts. You can only see one visible part. Now, what about oil and water? Is that a homogeneous mixture or a heterogeneous mixture? By the way, keep in mind, a mixture is a combination of two or more pure substances. Oil and water do not mix. You can visibly see two distinct parts. Now, water is more dense than oil, so the water layer is going to be below it. The lighter oil layer is going to be above it. So because oil and water do not mix, you can see it's a heterogeneous mixture. You could see the two visible parts.
Let's use the mixtures that we did together to understand the two types of mixtures. Okay? Let's check, let's observe the first and the third mixture. What are the components of the first mixture? Sugar and water, right. What are the components of the third mixture? Salt and water, good job. Can you see the sugar particles in the mixture? Can you see the salt points or the salt particles in the mixture? No, good job. So how many phases or levels or colors does this mixture show? Take a look. In the first cup, in the third cup, how many colors is there? How many phases is there? One, good job. So these two mixtures are called homogeneous mixtures since they show only one phase. A homogeneous mixture shows one phase, one color only. Let's observe the second mixture. What are the components of the second mixture? Sand and water, right. Can you see the sand particles? Yes, we can see them, correct. How many phases or levels or colors does this mixture show? Yes, two, good job. We can see the sand color and also the water color. Good job. So is it a homogeneous mixture? No, since it doesn't show only one phase. This is what we call a heterogeneous mixture. A heterogeneous mixture have components that don't mix. Sand and water do not mix. The sand particles settle to the bottom of the jar. Okay, sand doesn't dissolve in water. So, the heterogeneous mixture shows different phases, and in our case, we saw two phases, the phase of sand and the phase of water. Again, heterogeneous mixtures show two or more phases. We know now that mixtures are divided into two groups, homogeneous mixtures and heterogeneous mixtures. Do you remember the mixtures that we saw in the previous slides? Let's try to classify them as homogeneous and heterogeneous mixtures. Take a look on the plate of candies. This is a mixture, but how many phases or levels does it show? 1, 2, more than 2? That's right. So this is a heterogeneous mixture since it shows more than 2 phases, more than 2 colors. Take a look on mud and water. How many phases or levels does it show? How many colors? Good job, 1 color. So is it a homogeneous or heterogeneous mixture? Perfect, homogeneous mixture. Orange juice. How many phases does a mixture of orange juice show? 1 phase, correct? So is it a homogeneous or heterogeneous mixture? Homogeneous, good job. What about chocolate and milk? How many phases or levels does it show? 1, good job. So is it a homogeneous mixture or heterogeneous mixture? Well done, dear. It's a homogeneous mixture. Good job. Coffee now. How many phases or levels or colors does a mixture of coffee show? How many colors? 1. Good job. So is it a homogeneous mixture or a heterogeneous mixture? Homo? Excellent. Homogeneous mixture. Let's talk about tabbouleh now. Take a look on the picture of the tabbouleh. Does it show 1 color? How many phases or levels does it show? 1? No, that's right. So it shows more than 1. We can see the colors of the tomato, of the vegetables in it. So it shows more than 2 colors. It shows different phases. So is it a homogeneous or heterogeneous mixture? Heterogeneous, excellent. This is a heterogeneous mixture. What about a mixture of cookies and chocolate? Since we can see the chocolate chips in it, that means that we have more than 1 color. So this is a heterogeneous mixture. Good job. Let's continue. What about the mixture of rock and sand? How many phases or levels or colors does this mixture show? More than 1 level, that's right, good job. So is it a homogeneous or heterogeneous mixture? Perfect, this is a heterogeneous mixture, good job. What about a soft drink? Pepsi. Imagine that you're drinking Pepsi now. How many phases or colors does a mixture of soft drink show? 1 color, excellent. So this is a homogeneous mixture. Good job. Okay, water and vinegar. We mixed water with vinegar and we got this mixture. How many colors does this mixture show? 1 color, perfect. So is it a homogeneous or heterogeneous mixture? It's a homogeneous mixture. Perfect, good job. Milk now. A mixture of milk. We mix some sugar in the milk. Okay? Take a look on this mixture. How many colors, phases, or levels does a mixture of milk show? One level. Perfect. So, is it a heterogeneous mixture? No, it is a homogeneous mixture. Good job.
What are some examples of homogeneous mixtures and heterogeneous mixtures? Answer. Homogeneous mixtures are mixtures in which the constituents don't appear separately. 1. Blood. 2. A sugar solution when the sugar is completely dissolved. 3. A mixture of alcohol and water. 4. A glass of orange juice. 5. Salty water, where the salt is completely dissolved. 6. Brewed tea or coffee. 7. Soapy water. 8. A diluted solution of hydrochloric acid. 9. Hard alcohol. 10. Wine. In heterogeneous mixtures, the constituents appear separately. 1. Oil and water. 2. A soil sample. 3. Sandy water. 4. A carbonated beverage or beer. The CO2 gas appears separately within the liquid. 5. Orange juice with pulp in it. 6. Water with ice cubes in it. 7. Chicken noodle soup.
And guys, here is another example of mixtures. A mixture of pebbles, sand, salt, and water. Mixtures come in many forms and phases, and as we said, we can separate them, right? The kind of separation way depends on the kind of mixture it is. So can you think of a way to separate a mixture of pebbles, sand, salt, and water? Yes, we can see the pebbles with our eyes, right? How can you separate the pebbles from the other components of this mixture? Yes, that's right, we can pick them out. So, the pebbles can be removed or separated from this mixture by sorting. So, you can pick the pebbles out from the mixture or sorting them, okay? And this way, we separate pebbles from the mixture. We will still have the sand, salt, and water mixed together, right? We remove the pebbles. Now we still have sand, salt, and water. What can you do to separate the sand from the salty water? Good job. You can use a filter like we did before. So the paper filter will help us separate the sand from the water, since the filter paper will catch the sand particle and will allow the water to pass through it. This way, we separated sand from salt and water. The salt is now dissolved in water. We cannot see the salt in the water. What is one way to separate salt from water? Evaporation. Excellent. So we can leave the salty water in the sun for many days, or we can heat the mixture. This will let the water evaporate, leaving the salt behind. So now we have separated the components of this mixture. And we were talking about salty water. How does seawater taste? Is it yummy? No, it's salty, right? So the seawater tastes salty. It has salt in it. But can you see the salt particles in seawater? No, we cannot see them. So salt water is called a solution since the salt particles are dissolved in it. We cannot see them. Okay? Again, seawater tastes salty because it contains salt. But we cannot see the salt particles. What happened to the salt particles? They are dissolved in the water, right? This is what we call a solution. Okay? So, the solution is a special kind of mixture in which we have a component or something that has dissolved in something else. Can you separate the salt from the water by your hand? No, you cannot. The salt particles have dissolved in the water. This is what we call a solution.
Mixtures and solutions. Now, a mixture is anything made by combining two or more different substances. For example, if you've ever eaten a fruit salad, you've seen a mixture. You make a fruit salad by mixing together blueberries, raspberries, kiwis, grapes, and any other fruits you'd like. Now, a key feature of a mixture is that the substances do not react with each other. For example, in your fruit salad, nothing has changed about the fruit just because you've mixed it together. If you wanted to, you could separate out each individual fruit and see that nothing about it has changed. Now, there's one more type of mixture. It's called a solution. A solution is a mixture where substances are spread out evenly. The best example of this is to think about putting a spoonful of salt into water. If you put the salt into the water and stir, the salt dissolves, making it look like it isn't there anymore. But what's actually happening when you dissolve salt in water is that the particles of salt are spreading out evenly among the water. You just can't see them anymore. In solutions, the substance that's dissolving, which here was the salt, is called the solute. And the substance that things are dissolving in, which in our example was the water, is called the solvent. An easy way to compare mixtures and solutions is to think about taking a spoonful of each. If you were to take a spoonful of fruit salad, one time you might get a spoonful of blueberries, and the next time you might get a spoonful of raspberries. Each time you take a spoonful, it would be a little bit different. But in a solution like salt water, every spoonful you would take would be just as salty. There will be no extra salty spoonfuls because it's all mixed evenly together. Now let's practice identifying mixtures and solutions together. Let's start by deciding if this bowl of Cheerios represents a mixture, solution, or neither. Well, what is the definition of a mixture? Remember that a mixture is anything made by combining two or more different substances. And in our bowl of Cheerios, assuming there is no milk, do we have two different substances? No, all that's in this bowl are Cheerios, so this is neither a mixture nor a solution. Now let's look at another bowl of cereal. Imagine pouring yourself a bowl of Raisin Bran. Well, what is being mixed together in a bowl of Raisin Bran? Well, Raisin Bran is made by mixing together both raisins and cereal. So what is Raisin Bran? Raisin Bran is a mixture, but not a solution. It's a mixture because it's made of two different substances, but it's not a solution because it's not evenly mixed together. If you were to eat a spoonful of Raisin Bran, sometimes you get more raisins, while sometimes you get more cereal. Because it's not evenly mixed, we cannot call it a solution. On the other hand, this is an example of a solution. When I take this flavor and I squirt it into a cup of water, it makes a solution. Why is this called a solution? This is called a solution because the water and the flavoring are evenly mixed together. Every sip you would take from this cup would taste exactly the same, because the flavor and the water have spread out evenly. Now it's time for you to practice on your own. Here is a bowl of trail mix. What does this represent? This bowl represents a mixture. Two or more things are being mixed together, but they are not evenly mixed. If you were to grab a handful, sometimes you'd end up with a bunch of M&Ms, while other time you might end up with a bunch of nuts or raisins. So this is a mixture, but not a solution. Next, here's a spoonful of sugar being added to a cup of tea. What does this represent? Well, this would represent a solution, because the sugar and tea will become evenly mixed together. Every sip will be just as sweet as any other sip.
So basically, a solution is two substances that are evenly mixed together. Let's go for some examples of solution that we can see in our daily life. Detergents and water. Your moms need these kinds of solutions to clean clothes, dishes, where the detergent dissolves in water. Soft drinks. As we said before, these kinds of drinks are made of water, sugar, and gases. And since the sugar and gas particles are dissolved in water, we can consider soft drinks as solutions. Sugar in water. After adding a spoon of sugar to the water and stirring it, we can see that the sugar particles does not appear anymore in water. Okay, so the sugar dissolves in water and we can tell that this is a solution. That's right. Why is salty water a solution again? Who can tell? Can you see the salt particles after stirring the mixture? No. What happens to the salt particles in water? Good job, they dissolve. Excellent. So, the salty water a solution because it contains salt particles that are dissolved in water. We cannot see them anymore. Good job.
Solutes plus solvents make solutions. A solution is a mixture in which the particles of the mixed substances are so small that you can't see them, even under a microscope. The most familiar examples of solutions are solids dissolved in liquids. The two components are given special names. The substance that dissolves is called the solute, and the substance it dissolves into is called the solvent. For example, when you dissolve sugar in water, sugar is the solute and water is the solvent. We can also say that sugar is soluble in water because it dissolves easily. But sugar is insoluble in other liquids, such as oil. Water is a good solvent because it can dissolve a large variety of substances. We depend on this fact to stay alive. For example, one of the ways we digest food is by dissolving the water-soluble parts of it, such as salt and sugar in saliva, which is over 98% water. The plasma in blood is a water-based solution too. It carries solutes such as salt, sugar, and proteins around the body to where they're needed. As well as solids, some gases dissolve in water, and this is important for life as well. Fish stay alive by using their gills to extract oxygen dissolved in seawater. Shellfish, crabs, and prawns use dissolved carbon dioxide and salt to build their shells. Solutes plus solvents make solutions, a type of mixture we cannot do without.
So science has special names for everything. We call a solution every mixture made of two substances that are evenly mixed together, where one substance has dissolved in another substance. A solution is made up of two parts. One of them is called the solute and the other one is the solvent. A solute is the substance to be dissolved, and in our case, it's the sugar. The solvent is the one doing the dissolving process, and in our case, it's the water. Usually, there is more solvent than solute. You know now that a solution is made by dissolving a solute in a solvent, right? So, solute plus solvent equal solution. Knowledge. Do you know how to answer this question? What is the solute? What is the solvent in each of these solutions? 1. We mixed water with ink. What is the solute in this case? And what is the solvent? You have 5 seconds to answer this question. 5, 4, 3, 2, 1. What did you say? The solute is ink. Good job. And what is the solvent? It's water. Perfect. So the solute is ink and the solvent is water. We have a solution of ink and water. The ink has dissolved in water. That's right. 2. We mixed some salt in water. What is the solute in this case? What is the solvent? Again, you have 5 seconds. 5, 4, 3, 2, 1. Yes, what is the solute? Did you say salt? Good job. And the solvent? It's water again. Perfect. So the solute is salt and the solvent is water. The salt particles have dissolved in water and we have a solution of salty water. Good job, guys. Let's now observe some other examples of solutions. In this slide, we have three solutions: coffee, A; water and vinegar, B; and a soft drink, which is solution C. Okay, what is the solvent in all cases? What did we use for dissolving different substances in the three cases? What is the solvent, guys? The solvent is water. Perfect. Good job. Let's look at solution A. What is the solute in solution A? What did we dissolve in water? Yes, we dissolved coffee. That's right. What is the state of matter of instant coffee? Is it solid, liquid, or gas? Good job. It's solid. So the instant coffee, which is a solid, is dissolved in water in solution A. Let's talk now about the second solution, solution B. What is the solute in this case? It's the vinegar, right? So what is the state of matter of vinegar? Is it solid, liquid, or gas? It's liquid. Good job. Solution C, which is a soft drink. Okay? In a soft drink, sugar and gas particles are dissolved in water. Let's talk about the gas particles. What is the state of matter of the gas particles? Are they solid, liquid, or gas? Gas, that's right. So we can see that solid substances or substances in a solid state, liquid state, and gas state can be dissolved in water. Okay, and an aqueous solution is a solution where the solvent is water. Cola, salt water, rain, salt solutions are examples of aqueous solution. Okay, again, an aqueous solution is a solution where the solvent is water. Aqua means water. For this reason, we say that aqueous solutions are solutions where the solvent is water. Guys, let's say that we found this bottle of water, and this bottle or this container contains a liquid, clear liquid that looks like water. Okay? This liquid can be just water, or else it can contain an aqueous solution, right? We don't know. What is one way that you can use to find out if this is just water or a solution? Great question, right? So think of it. How would you experiment? What would you do to find out if this liquid is just water or this liquid is an aqueous solution? What would you do? Leaving it in the sun or heating it. Perfect. So one way is we can take some of this liquid in a cup and we can leave it in the sun or we can heat it. Evaporation will help us figure out if the water contains something else or it's just water. If it has nothing in it, the whole amount of water will evaporate. What if we could turn the salt water into fresh water? Do you think that this is possible? Is there a way to obtain drinkable water from seawater? You may be surprised to hear, but many places are already doing it with a process called desalination. This process involves separating and removing high amounts of salt from fresh water. There are places around the world that do this job, and they are called desalination plants. So the desalination process helps us turning the seawater into fresh, usable water. How can we get salt now from salt water? What can we do? Yes, using the evaporation process. Salterns are buildings or places where salt is made by boiling or evaporation. So a saltern is a set of pools in which seawater is left to evaporate to make salt. Do you know that many salterns are found in Lebanon? Okay, so salt and sugar dissolve in water. Sugar dissolves in water and in alcohol. But salt dissolves in water, but it does not dissolve in alcohol. Okay? Now you know everything about mixtures. You know how to define a mixture or a solution. You know how to distinguish between a homogeneous and a heterogeneous mixture and to identify a solute and a solvent in a solution. And I think you know what an aqueous solution is. If you still have any questions, Miss, I'm always ready to answer them. Okay? Stay safe. I love you so much, and I can't wait to see you again. Bye bye.